Hello guys, my name is Sharma. Today I am demonstrating my project. It is Bluetooth multimode project, Bluetooth controlled multimode project. So first of all, I will discuss about the components that I have pasted over here, and after that I will show the connection between the IC and the components, and after that I will tell you what's the software part that I have done for this, what the programming part that I have done for this, and after that I will show the working of my project. So first of all, look over here, this is my project. So here, this is the power supply. It's a DC jack. Okay, it's a DP/DT switch. It's a voltage regulator, resistance, and a LED. So it's the 5 volt power supply. I'm giving 9 volt from the battery over here, and I'm getting out 5 volt DC. So I'm using here DC jack because sometime I want to check it from my adapter. You can use PBT connector also here, and you can connect. I show you the PBT connector like this. This is my PBT connector. You can connect one terminal of my battery, that is positive, to this one and to the negative, and you can paste it here like this. So it's your choice what you want. So this is a DP/DT switch. I will tell you how it works later in my in this video. So after this is a atmega 8 AVR microcontroller that I am using here for this whole project. So here this is a Bluetooth. Why I am using Bluetooth? Because I am doing the transmission, or I am doing reception as well as transmission or the communication with the help of UART module, and I am controlling that UART module with the help of Bluetooth. So that's why I'm using Bluetooth over here. So it is a LCD 16x2 LCD. Why I'm using this? Because when my robot will shows the moments, suppose it's moving forward, so I want that it should display it on the LCD, on this LCD. If my robot is moving forward, it will show forward. If my robot is moving backward, it will show backward. If it's moving right, so it will show corresponding. So this is L29 3D motor driver. These are the capacitors over here. Those are for filtering purpose. These are my IR sensors, IR sensor module. Why I am using them? Because my robot will work also in a detection mode. If anything will come in front of these IR sensor, these sensor will sense them and will send the command to my microcontroller, and my microcontroller will work accordingly. Okay. After that, it's the chassis. Okay, here I will show you. These are using these are the 4 DC motor I am using, but two of them are connected to the L29 3D, and these two are shorted. Okay, these are shorted to them. Okay, these are my wheels. It's a 12 volt external battery that I am using to drive L29 3D, because L29 3D needs 9 volt or 12 volt particular to drive its motors. So these are the capacitors over here. So this is little bit of about my project. These are the components that I am using. So I will discuss all components one by one over here. Okay. So here I am using DP/DT switch. So positive of this DC jack will come to the DP/DT switch. DP/DT switch is actually having 6 pins. By those 6 pins you can switch either positive as well as negative, but here I am only switching positive supply. Okay. So there are 3 pins. Out of 3 pins, 2 pins are internally short. I have to check them from my multimeter. I will check them. Okay. Which of 2 are from these 2 shorted pin. I will take one common pin and I will connect that common pin to my first pin of 7805 voltage regulator. Okay, and the first pin which is not shorted, I will connect to my DC jack positive line. Okay, this is 7805 voltage regulator. Because I am here using 9 volt, but my chips, okay, my IC atmega, that works particularly on 5 volt supply. So for that I have to provide a 7805 voltage regulator. Okay, I am using 7805 voltage regulator. It will regulate up to 5 volts. So first pin will be connected to the positive line from the DP/DT switch, and the second pin of this 7805 will be grounded, and from the third pin there will be plus 5 volt supply that will be generated by this regulator. Okay, here
I have using one resistor, 220 ohm resistor, and one LED to check that my power supply is working or not. Okay guys, this is plus 5 volt supply which I will use further in my circuit. So I will check you here in my project through multimeter. Is there coming 5 volt or not? It will approx 5 volt. Okay, it will not be fully 5 volt. It will be approximately 5 volt. It will be 4.9, 4.80. So it will be like this. It will work. Okay, this I switch on the my project power supply. Okay guys, so look here, I will put my positive, this is my positive, this is my negative. I will set it from the voltage DC voltage. Now how I will check this? Here this is the positive terminal, I will check here, and now look at here multimeter 4.96. It's near about 5 volts. So I'm getting actually 5 volts. Okay. So guys, this was my power supply part. Now next part I will show you here. Now in this here I will tell you about what I have used. This is atmega 8 IC. Here look here, this IC I'm talking about, this IC atmega 8 microcontroller. It is having 28 pins, out of which 23 pins are GPIOs, that is general purpose input outputs, and 5 pins, those are special purpose. Okay, which of them are the 5 pins? This is VCC, ground, AREF, and AVCC. These are 5 pins. They are special purpose, and all other they are general purpose. So in this atmega 8 there are 3 ports. Port B, which is having 8 pins. Port C having 7 pins, and port D having 8 pins. So all these are equal to 23 pins, 23 general purpose input output. Okay guys, so this is my atmega 8 part. So first of all I will tell you about this part, Bluetooth part. Okay, as I already tell you that I am using UART for my communication, UART module for my communication. So these are the RxD and TXD, PD0, PD1. These are the RxD, reception or transmission of the microcontroller or UART module. This is my Bluetooth that I have 6 pins of Bluetooth over here. First pin is the state, second is RX, means receive, third is a TX, transmit, fourth is the ground, and fifth is a 5 volt DC. Okay, so I will connect RX of the Bluetooth to the TX, means a reception to the transmission, and TX to the RX of my microcontroller. Okay guys, so here I am using LCD 16x2 LCD. LCD is having 16 pins. Okay, first pin of LCD is ground, second pin of the LCD is VCC. We will give 5 volt DC, 5 volt power supply to this LCD. Third pin of LCD is a contrast one. Contrast means you have to set the brightness of the LCD. Okay, for that we have used potentiometer. Potentiometer is having a 3 pins, first, second, third. So second pin of the potentiometer is connected to the contrast pin, third pin of the LCD, and first or third pin they are connected to power supply as well as ground. Okay, you can connect this third pin give you 5 volt, or you can give first pin ground. Okay, fourth pin is the RS means register select. Okay, there are two type register. There is a command register as well as a data register. Okay, if I will give RS is equals to 0 in my programming, it will select command register. If RS is equals to 1, it will select data register. Okay, after that read and write, it is generally ground. Then after enable, so why we use enable here? Because this is the enable pulse. Okay, this is a rising edge, it means the enable has been started. This is the time, this edge, this is the time when the data will go to the register, and after this is the time after which the data will be displayed on the LCD. Okay, I will give you all this description in my programming part. So from 17 to 14, these are the data lines. These are 8 data lines, D0 to D7. Okay, so 15 pin of VCC and 16 is the ground. Here I am using here 4 data lines. You can use 8 as well as 4 data lines. So these 4 data lines are connected accordingly. D4 is I am connecting D4 to my PD4, D5 to my PD5, D6 to my PD6 and D7 to my PDC, and you can connect them according to yourself. Okay, so 5 volt DC is here, 5 volt DC here, and this is ground. Okay, this was the LCD part. Now I will tell you I am using these two IR sensors over here for the detection mode. Okay, these will detect the obstacle. If any obstacle, suppose any obstacle will come here, it will sense that, it will send the command to my microcontroller, and my robot will work according to that. Clear? So I will tell you something about, little bit about my IR module. This is the IR module. It is having 3 pins: V out, ground, and VCC, and is having potentiometer. You can change the the distance, even the sensing power of this IR sensor by this potentiometer. VCC, ground, V out. Okay, this is the, we will give 5 volt here, we will give ground here, and V out, because here for this project, for this Bluetooth control project, I am using interrupt 0 for the IR module. So I will connect V out of this to the interrupt 0, that's the PD2 pin, and same here to the second IR module, it will be connected to interrupt D0. So this was my IR sensor part. Okay, now here guys, I will tell you about L293D. This is the motor driver IC. This is the IC, motor driver, and how it works, and what is the IC description I will tell you here. This, it is having 16 pins. Okay, first pin is have enable, second is input 1, third is output, fourth is ground, fifth is ground, sixth output 2, seventh input 2, and 9 volt and 12 volt power supply. That will be external battery we will use for this. Okay, it's enable, and these are corresponding to that. Okay, so first of all I will connect input 1 to my PB1, because I have connected, I am using B port. I have connected these 4 pin of B port, PB1, PB2, PB3, P4 to L293D input pins. So this is my input 1 that I will connect to the PB1. So input 2 I will connect to PB2, input 3 I will connect PB3, and input 4 I will connect PB4. Okay, so there will be corresponding output. This will be output 1, output 2, output 3, and output 4. And I am placing a crystal oscillator. So guys, here I am using ceramic capacitor, 0.1 microfarad capacitors. I am using them for filtering purpose. Okay, after that I have connected motors. This is motor 1, this is my motor 2. So these 2 wires of motor, this that I have connected to this ceramic capacitor and to the output of this. So here the output will come, 1 output, 2 output. These are the PBT connectors. I am using motor. This is a motor inputs coming from here. This I have placed motor here. These are the 2 inputs that are coming over here. So these are I am connecting them accordingly. Okay, so this is motor 1, motor 2 connected. Okay, it is a enable 1, enable 2. We will give plus 5 volt, 5 volt supply here, and also to the VCC, it is a VCC, we will give plus 5 volt. This is 9 volt or 12 volt supply. Okay, we will give external supply, we will use external batteries, external supply, 12 volt supply, because I am using 5 volt regulated supply, so I can't give 5 volt here. So I have to use a battery. I have placed a battery here. It's a here I have fixed it actually. So it's a 12 volt battery. Okay, external. So I will connect it to this pin. Okay, positive of to this pin, and a ground to the common ground of this particular project. So this was the part of L293D, and how the connections of the motors are there, and how I have connected. And these are the ground, foreground. I have to make all them ground. Okay, remember one thing, all the pins should be connected according to this particular circuit diagram. Okay guys, so guys, this is how I have connected these things to controller. So I have connected Bluetooth, IR sensors, extreme cross to LCD, L293D, and these are the motors I have connected. So guys, now I hope that you understand little bit. Okay, now I will tell you the programming part. Okay, software part. So guys, I hope you understand the hardware part of this project. Now I am going to tell you about the software part, how I have made the program for my Bluetooth control robot. Okay guys, look here. So guys, here I am using Atmos Studio software for my programming of AVR. So the programming will be like this. So first of all, I will declare a header file, include AVR input output, and include AVR interrupt.H because I am using interrupt for the detection mode. So here I will come here main. So this is int main. First of all, I have set the all DDRs. Okay, accordingly DDR. So I have used initialize here USART 51 means it's a baud rate because our baud rate means the transmission rate 9600. So I'm using 51 here for the USART initially. You can check it in your data sheet, in your atmega A data sheet. You can check it. Okay, here I have initial at LCD. So these are all the registers of interrupts MC, UCR, GICR, GIFR for setting interrupt SEI. Okay, here I'm using USART receive. Okay, and USART transmit. This USART transmit, and I'm using mode 1 function here. I will tell you after some time what is mode 1 function. So this is a USART receive and USART transmit. So it means that whatever I will transmit on USART, I will receive it back on my Bluetooth. Okay, now this is my interrupt part. ISR, you have to set interrupt like this. ISR interrupt 0 vector because I am using interrupt 0. This is LCD. I am using here LCD command shift. Why I am using LCD command shift? Because I am using 4-bit LCD. That's why LCD command shift. I will tell you about this. LCD string I'm using because I have to show the detector mode. What if my IR sensor will detect something? So that I want to show it on my LCD. That's why I'm using LCD string. Says the port B is equal to 0 cross 0A, that I have given the command. If anything will come in front of the robot, it will detect something, and after that it will move backward. 0 cross 0A for me it's a backward command. So I have given delay. After this delay, this backward will be stop and my robot will be stop. Now these are the void USART initialize function. Accordingly, you can check it in your datasheet. Use atmega datasheet. USART transmit. So USART transmit. You can check also. It is all available in atmega data sheets. USART. These are USART receive function. So this is void LCD command. This is a LCD function. I'm using port D because I have connected my LCD to PD4, PD5, PD6, PD7. That's why I'm using. This is for RS. This is for setting enable, and this is for switching of the enable. So I am doing this accordingly. This was the function for LCD command. Now this is the LCD data function I am using here. Okay. These are the LCD command shift. Okay, this is command shift. This is a LCD string I'm using. Why I'm using LCD string? Because I have to, if I have to show the detection mode, forward, backward, for that I have to use string so that LCD will show that string. That's why I'm using this function. Okay. Okay, so this is a LCD data shift function for LCD data shift. Now it's for initializing LCD. Okay, these are the commands to initialize LCD. Okay, so I was talking about the mode 1 that I have I have used here in my main. So what is mode 1? It's a function that I have called in main, and what that function tells here, mode 1 is a function I have made if A is equals to F. If I will give the command F, okay, then the motor will be in forward direction, the robot will move in a forward direction. Else if I will give B, so it will be backward, and L for the left, and R for the right, and S for the. So guys, here I am using, to control my robot, I am using Bluetooth SPP Pro app. Okay, so I have here I have initially I have given supply to my Bluetooth module, Bluetooth here. So I will connect HC05. I will connect this connecting. There are three modes: byte stream mode, keyboard mode, CMD line mode. You people can select according to your programming. So that's why I am using here byte streaming mode, because it suits for me, it's suitable. So here I will give my commands, because I am you'll be a little bit confused that I selected F, R for F for forward, R for right, L for left, and B for backward. So I will give the commands here. If I will press F, so this command will be given to this Bluetooth, and this Bluetooth will forward this command to my USART module. And after receiving that USART will receive my command, and the microcontroller will forward that command to L293D, and the motor will be driven accordingly. So guys, so this was how I will use Bluetooth SPP Pro. Okay, you can use many other apps. There are certain other, there is a BT something like app, BT controlled. There are many, you can search them on the Google. There are many. So I am using Bluetooth SPP Pro. Okay, so this is the app that I have used. So after this, I will demonstrate you how my project will work. Okay, how my command will work through this SPP Pro app. Okay, I'm showing the working of my project. As I already told you, I am using Bluetooth SPP Pro. So I will scan for the Bluetooth. It's scanning. Okay, HC05 is that Bluetooth which is mounted over there over my PCB. Now I will connect it. Connect. It's connecting. It's taking time. So I'm using. So guys, here I am giving F for the forward. Now look at the robot. The robot will move forward. It's moving forward. I will give stop one. It moves. It's stopping. Look here. I have given F. So as I told you, F and S. Okay, for stop. Now I will make it backward for B. Forward. Stop. Backward. Stop. Forward. Backward. And stop. Once again. Forward. Backward. Now I will make this robot a little bit forward, then I will rotate in a right direction. Look here how it will work. Okay, now stop. I will move this robot in the left direction. Little bit I will make it move first forward, then after left direction. Look how it will work. Okay, and stop. So this is how it moves in the left direction. So guys, now look here. I am moving my robot on interrupt. Okay, how the interrupt will work. Okay, this is how it works. Okay. So guys, thanks for watching my video. I hope it will help you in your projects. So if you like my video, like or comment.